Good evening, folks. My name is R. Chandrasekhar, and I will be conducting the program Hands-on Machine Learning, Deep Learning, and NLP. The key part about this program is I will also be covering the state-of-the-art topics, so-called SOTA, such as transformers and BERT. First, let me introduce myself. I have over 27 years of experience in the tech world. I did my BTech in Chemical Engineering from IIT Varanasi and went on to do MS in Computer Science. I worked in the US for 3-4 years and came back to India to co-found my own company called Apions. I was there till 2010, and after that I worked in many companies developing products and AI solutions. And the companies were Pratham, Meritrack, Metric Stream, Common Floor, Team Lease. After that, I found my own company called Native AI. They have delivered training to companies like Samsung, Honeywell, TCS, Mahindra Comviva, PwC, Bridge Labs, and many other companies. I have also trained retail attendees such as you, coming from various companies such as Amazon, SAP Labs, VMware, and so on. I have also developed a number of solutions using ML. I have created a facial detection platform. I have created object detection platform using CNN and SSD for a company. I have created ML solution suite to predict the customer behavior analytics. Right? I have also created solutions in NLP space, starting from the traditional naive base right up to RNN and BERT. Okay. Now let me explain to you the nature of this program. This is an 80-hour program, so there will be a lot of time to help you understand the concepts behind ML and also actually code many of the machine learning models in Python. Right? I cover both the conceptual and practical part. In each of the algorithms, I will be talking about the algorithm, explain the algorithms, and give you use cases where it can be used, where it cannot be used, and also most of them make you write code in Python. At the end of this, you will be able to answer the following kinds of questions. First, why do you choose this model over other model? Right? What all kinds of models can you use for solving various problems? How do you go about doing an ML problem, solving ML problem? How do you go about getting data? Right? What is the most complex part of a machine learning? Is it writing the algorithm for ML model? Is it getting data? Or is it hyper-tuning the parameters? Or is it something else? Right? And you will also have the confidence of having written code for many of the machine learning models. So you will kind of know how to go about coding for an ML model after doing all the pre-processing steps required for it. Now let me describe in detail about this program. This program is a hands-on one, so it expects you to know Python. In case some of you are coming from Java, C++, C#, or other such languages, I have a 4-hour intro on what is Python. Now, there is a lot of confusion in the industry among the people on what is data science, what is machine learning, what is deep learning, what is AI. I address this confusion in the very first session of machine learning. As mentioned, I teach what is data science, what is machine learning, what is deep learning, and what is NLP, and I say areas where these are related. After that, I cover the necessary math for general machine learning such as calculus and linear algebra. After that, I talk about supervised, unsupervised learning and what are the supervised machine learning algorithms. I start with the first supervised machine learning algorithm called k-nearest neighbor. I take you through the use case, where it can be used, where it cannot be used, and I'll make you code a practical problem using KNN. After that, I talk about naive Bayes. I will cover the requisite probability for that, right? And I will also take you through the use cases of naive Bayes and make you solve a problem using naive Bayes. I will also show a lot of code I have written in the naive Bayes algorithm. Then I talk about decision tree, which involves you to understand the concept of entropy, which also I will cover as the part of prerequisite math, and then we will build decision trees. We will also know what are the pros and cons of decision tree, when you can use, when you cannot use, and a derivative of decision tree commonly called as bagging and boosting. I'll cover that in detail, and I cover extensively the first go-to algorithm for a non-deep learning problem in the commercial, for solving commercial applications in ML, called gradient boosting. Okay, I'll be talking about XGBoost and AdaBoost. Then I will be spending some time in linear regression. Linear regression and logistic regression are foundations to understand neural networks. I spent a lot of time in linear regression and logistic regression. I take you through the concepts. I'll also give you a problem to solve and also make you code for one use case. Then we go into neural network. Neural network is foundation. You have to understand neural network to know about deep learning. Right? I cover the math and also the applications of neural network. What are the pros and cons? And how do you solve the problems using neural network? I discuss a lot on Keras framework and make you solve a problem using Keras network, Keras framework. After that, we are going to I'm going to give you a break. It's not a holiday break. It's actually a break to give you a time to solve a project. I will give you a mini project and I'll have you solve that project using any one or combination of the ML algorithm which I've covered before. I will help you solve that. After that, we will get into deep learning. I start with CNN, which stands for Convolutional Neural Network. I talk about what is convolutions, what is padding, etc. Then I cover other concepts such as object localization and how do you do object localization. Many of the algorithms you may be using for object localization, such as RCNN, YOLO, SSD, etc. Then I talk about various pre-existing networks and how do you solve a image related problem. Do you start from scratch or you use existing network? I talk about a concept called transfer learning. After that, I take you through RNN. RNN stands for recurrent neural network, and in this I will be talking about what is an RNN, what are the various types of architecture, and how do you solve the problems using RNN, especially NLP related problems, and why RNN is becoming more popular and replacing the traditional NLP algorithms like bigrams, trigrams, etc. After that, I will be covering the second concept of NLP called word-to-vec, word embedding, and one more new topic that has come just about the last couple of years, that's called the SOTA, state of the art, and that is transformer and BERT. What are some of the problems you can solve using RNN? What are the problems you cannot solve using RNN due to various reasons, which is why you choose an allied technologies like BERT, maybe ELMO, embedded language model output. Okay. After that, we will be talking about unsupervised learning. In the unsupervised learning, I'll talk about K-means clustering, right? And how do you solve problems where you have unbalanced data set or when you have huge amount of data? What are the metrics you'll be choosing for measuring the algorithm? And finally, I'll be talking about reinforcement learning and DQA. With this, folks, I'm sure you will have the confidence of knowing how to approach a machine learning problem, how to decide which algorithm to use, and know what are the steps in data collection, in building the model, and how you will tune the model, and how you choose various hyperparameters to tune the model. I wish you all the best, folks, and hope to see you there soon. Thank you.